Lesson 30 is a super simple section because it's just a review of matrices. In lesson 31, we're going to do a little bit more with matrices. So a quick review of them. So if you add or subtract matrices, so if you have W plus Y, remember you're just adding your corresponding locations. So you would add the 3 and the 1, the -2 and the 4, the 1 and the -2, and the 0 and the 3. And your result would be 4, 2, -1, 3. Okay, so obviously they have to be the same dimension. When you talk about dimensions, this one is a 2 by 2 because there's 2 rows and 2 columns. This one is a 2 rows and 3 columns because columns are up and down like columns in a house. 2 by 2 and a 2 by 3. So you can only combine the ones that are the same dimension. So if you have x minus z, then you're going to take x minus z, so 4 minus 2 is 2, 7 minus a -2 is 9, 2 minus 3 is -1, 4, 1, and -5. Okay, so then the next one is x plus 2y, so this is what we call a scalar, multiplying by 2. So I'm going to go ahead and write out x, which is 4, 7, 2, 5, 1, -1, and I'm going to add it to 2y. So I'm going to multiply the 2 into every single term of the matrix. So 2y is going to be 2, 8, -4, and 6. But when you do that, you can see that these aren't the same dimensions, so this is actually not possible. And the next one, 3w, you would have 9, -6, 3, and 0. And then I'm going to go ahead and say plus, and then I'm going to multiply a -2 into the y. So I'm going to have -2, -8, 4, and -6. So when I do add those together, I get 7, -14, 7, and -6. All right, so that's pretty easy. Hopefully you'll remember that. You can multiply matrices A and B if the number of columns in the first one equals the number of the rows in the second one. So what I always said is that the numbers in the middle had to be the same. So if you have an m by n and you're multiplying by an n by p, you want the n and m to be the same thing. And then basically if they are, you are allowed to multiply and you ignore those middle numbers. So we end up getting an m by p matrix. So again, let's write down the dimensions for each of these. So this is a 3 rows and 2 columns. This is a 2 rows and 3 columns, 2 by 2, and a 2 rows and 3 columns. So if you have w times x, it's kind of an interesting method. So you have 3, 1, 2, -2, 0, -1, and you're multiplying by x, which is 4, 7, -2. 5, 1, -1. And we know that this is a 3 by 2 multiplied by a 2 by 3. So we ignore those middle numbers once you verify that they're the same. So we're going to end up getting a 3 by 3. So what I often do is I'll draw the little slots so I don't miss anything. Okay, and if you remember, I always say it's the rubbing your belly, patting your head, rubbing your belly method. Where you have to do 2 things at once. So for this one, you're going to go over, and with your other finger, you're going to go down, and you're going to match up the spots. So you have 3 times 4, those are the first numbers in those locations. So that's going to be 12, and then you add it to -2 times 5, which is -10. And then you move. So you're still in the first row, but now you're going to be in the second column. So you have 3 times 7, the first numbers, so 21, and then you multiply the second numbers together. So -2 times 1 is -2. And you continue this process. So 3 times -2 is -6, added to 2. All right, and now that we're moving on to the second row, we can't use the first row anymore. So now we move down to here. So if I want this first position, I'm going to do the first row and first column, or second row and first column, right? So I'm going to have 4 times 1 is 4, plus 0. I'm going to have 7 plus 0, and I'm going to have -2 plus 0. And then the last one uses the third row, so I have 8 plus -5, 14 minus 1, right, plus -1, and -4 plus 1. So you should get the final matrix is 2, 19, -4, 4, 7, -2, and 3, 13, and -3. So you can check all these with your calculator if you want to. I might have errors, so be looking for those bonus points. All right, so when we do x times w, this one is going to be 4, 7, -2 multiplied by 5, 1, -1. And then W is 3, -2, 1, 0, 2 and -1. And you can verify 2 by 3 multiplied by a 3 by 2. The numbers on the inside were the same, so we cross them out. So we get a 2 by 2. But now there's going to be 3 numbers in each of the spots. Okay, so as I'm doing this, I have 4 times 3 is 12. And then I have 7 times 1 is 7. -2 times 2 is -4. And then I have 4 times -2 is -8 plus 0 plus 2. Then I have 15 plus 1 minus 2. And I have -10 plus 0 plus 1. So you should get 15, -6, 14, and -9. All right, the next one is x times y. So if you look at x times y, you see that you have x was 4, well, let me just do the dimensions, I guess. It was 2 rows and 3 columns, and the next one was 2 by 2. So this one is not possible because of those middle numbers. And then y times x, this one is possible because it's a 2 by 2 multiplied by a 2 by 3. So we're going to end up getting a 2 by 3. So y was 1, 4, -2, and 3. And x was 4, 7, -2, 5, 1, and -1. So I'm going to circle the rows in the first, the columns in the second. And like I said, I'm going to get a 2 by 3. So as I multiply first row, first column, so I get 4 plus 20. I get 7 plus 4. I get -2 minus 4. -8 plus 15. -14 plus 3. And 4 minus 3. So you should get the answers. Let me think. So 24, 11, -6, 7, -11, and 1. And then W times Z. W was a 2 by 3 matrix. And Z was a 2 by 3 matrix. No, wait, was that right? 2 by 2 rows. No, 3 by 2. Yeah, you actually can't do this one. It's 3 by 2. So 3 by 2 and a 2 by 3. So we're going to end up with a 3 by 3. So we have W is 3, -2, 1, 0, 2, -1. And the other one is 2, -2, 3, 1, 0, 4. All right, so we have rows and we have columns. So we end up getting, let's see, a 3 by 3 in the end. Okay, so I have 3 plus a -2. I have -6 plus 0. I have 9 plus a -8. I have 2 plus 0. I have -2 plus 0. I have 3 plus 0. I have 4 plus a -1, -4 plus 0, and 6 plus a -4. So it looks like 1, -6, 1, 2, -2, 3, 3, -4, 2 is our answer. All right, so hopefully you remembered multiplying. I went pretty quickly through that, but you can come to office hours if you get stuck. All right, so I do have a little note. It says the commutative property does not hold for multiplication of matrices. We know that because we can see x times y is different than y times x. So sometimes one of them is not even possible. The identity matrix, we write it as I. The 2 by 2 version looks like 1, 0, 0, 1. So sometimes I call that I sub 2. But like a 4 by 4 version would be 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. Okay, so we always say there's ones down the main diagonal, and then there's zeros everywhere else. Okay, and the identity matrix is like multiplying by 1. So basically, if you take any matrix A and you multiply by I, you get A out. And if you do I times A in that direction, then it actually is commutative. That's the one of the only ways that you can multiply and it is commutative. So we get A. The other way that we have commutativity, I don't know if that's the word, but we do A times A inverse, and A inverse times A. That would also work. All right, so if I multiply A by I, you can check this, but you should, I mean, when you do, 154, negative 3, and you multiply it by 1001, you should get the exact same thing, 154, negative 3. So you can check. And it works if you do the other direction too. You get A as well. All right, so if you see something that says find A squared, just know that you can't just square every single item. I don't know how many times I've graded tests when people say that the answer is 1, 25, 16, and 9. It just kills me. Please don't do that to me. So A squared we know is A times A. And when we multiply matrices, we circle the rows in the first and the columns in the second. So we're getting a 2 by 2. So we're going to have 4 plus 20. We're going to have 5 plus negative 15. We have 4 minus 12, and we have 20 plus 9. So your answer is actually 24. Is it 24? Oh, what am I doing? What did I get for? It's 1 plus 20. Sorry, 21. And I guys hate that when I find my mistakes. So we get 21, negative 10, negative 8, and 29. All right, so there's many ways to solve systems of equations with matrices. So if you remember in Algebra 2, we solved systems using inverse matrices. Okay, so it says for the system of equations on the 3 matrices below, verify that A times X is equal to B. So if you line these up and you had A times X, that means that you would have a 3 by 3 multiplied by 3 rows in 1 column, 3 by 1. So you end up getting a 3 by 1. Okay, so you don't have to write this, just kind of pay attention. So if I multiply, then I'm going to multiply 1 and X together and get 1X. And then I'm going to have negative 1 and Y together, so I get negative Y. And then I have 1 and Z together, so I get plus Z. So what does that equal? It equals 0. It equals that first spot there. So if you notice, that is coming from this equation, 1x minus 1y plus 1z equals 0. Okay, and so if you do each of these spots, so if I do 2, 1, negative 3, and then I multiply by the vertical matrix x, y, z, I get 2x plus 1y minus 3z equals this spot, 7. Okay, and that's the second equation. So that's how this works. Okay, so if you remember from Algebra 2, we always had the equation a times x is equal to b. So the coefficient matrix times the variable matrix equals the constant matrix. And if we wanted to solve, what we did on our calculator was A inverse times B. We actually did it by hand as well, though. Okay, so I haven't taught you how to find the inverse of a 3 by 3 matrix yet. You'll learn that in the next section. So we're actually going to use our calculator. Okay, so we want to go to matrix on our calculator. So hopefully y'all kind of remember this. And we want to put in A. Okay, so as I hit second matrix, oh, it's not letting me. Sometimes it's a little weird. All right, so second matrix, and you want to put in matrix A. So we're going to hit, go over to edit and hit enter. And we want A to be a 3 by 3. So do 3, enter, 3, enter. All right, and we're going to put in all those numbers for A. So I have 1, I have negative 1, I have 1, 2, 1, negative 3, 3, negative 2, and 0. All right, and I hit enter. Okay, so then when I would go back into my second matrix, I want to find what A inverse is. So you can do this on your calculator. You can hit enter under names. So, oops, I guess I need to clear out of there. So make sure that's still 0 there. So let me do second quit to get out of there. Now go back into second matrix. And I'm going to do A. So enter. And then you do inverse by just doing the x, the negative 1 button. So if I wanted to know what A inverse is, I could hit enter now. And I could see it. It's in decimals. So if I wanted to change it to fractions, just like normal, I do math 1. And I can see A inverse. So it gives it to me very nicely. Okay, obviously, when we're doing this in the next section and I show you how to do this by hand, you're not going to be able to use your calculator on the test. So this would be on the non-calculator portion. But I might ask some where it's, where you're allowed to use your calculator. So, and the reason I do this is because most colleges do ask this in their college math classes. So almost all freshmen take a class where they have to do matrices by hand. So I'm not just trying to be mean, I promise. All right, so that's A inverse. But what we really wanted was A inverse times B. So you could just do times and it would pull up the last answer, or you can go back into matrix. So second matrix and hit A, and then do inverse. Oops. And then do second matrix. Oh, I haven't put it in yet, have I? Okay, so we're going to go to second matrix and we're going to edit B. So go over to edit, and we want to put in B, and we want B to be the 0, 7, -4, and we want it to be vertical. So that's 3 rows and 1 column. And as you see, it shows up vertical, so that way you know that you're doing it right. Okay, and then do second quit. Okay, now I want to pull that up here. Okay, so I just kind of went in there. So second matrix B, and hit enter. Okay, and you get your answer. So again, if you wanted to see it as fractions, you can always do math 1. But it's telling us our answers are 11 over 2, 41 over 4, and 19 over 4. Okay, so that's our X, Y, and Z. So we'll go back here and we'll write the correct answers. So we have, oops. So we have 11 over 2 is X, Y is 41 over 4, and Z is 19 over 4. All right, so a matrix is called invertible if there exists an n by n matrix B such that A times B is equal to the identity matrix, and also B times A is equal to the identity. Okay, so we're going to talk about how to find the inverse of something like larger than a 3 by 3, but first we're going to do just the normal 2 by 2s. So it says, for the given matrices, verify that B is the inverse of A. So all you need to do is do A times B. You don't also have to do B times A. So if we do A times B, 1, 3, 1, 2, and we multiplied by -2, 3, 1, -1, when you do that, you can check, but you will get 1, 0, 0, 1. Okay, that is the identity matrix. When that happens, that means that A and B are inverses. Okay, so yes, they are inverses. All right, so if I was finding the inverse of matrix A, there's a formula for it, but this actually came from, there's like a little proof for it. So I'm going to show you how they came up with this. So it says find the inverse of matrix A, which is 2, 4, 1, 3. And what we're going to do is we're going to say that A times A inverse is equal to 1. So we're going to say 2, 4, 1, 3 times some kind of A inverse. So I could have called it A, B, C, D, but I called it X, U, Y, and V. Okay, and we want this to end up being the identity matrix. Okay, so what do we get when we multiply? So if I multiply this out, I get the equation 2x plus 4y has to equal 1, right, coming from here and here. All right, and then I get another one, 2x, 2u, let me write the u's and v's over here. So 2u plus 4v equals 0. And then the second spot, or the third spot, I guess, is 1x plus 3y equals 0. And the last one is 1u plus 3v equals 1. Okay, and what we do in order to find x, y, and z, or x, y, u, and v, sorry, is I do a system of equations. So I'm going to multiply this first with the second equation by -2. So I get 2x plus 4y equals 1, and I have -2x minus 6y equals 0. So when I add straight down, I get -2y equals 1. So y is -1/2. And if I go back into any of those equations to solve for x, I end up getting x equals 3 over 2. And then I do the same thing on this one. So if I multiply by, let's do -2, I get 2u plus 4v equals 0, -2u minus 6v equals -2. So I get v equals 1. And then if I solve for u in any of those equations, I get v equals -2. So that means my inverse matrix, A inverse, is x, which was 3 over 2, u, which was -2, y, which was -1/2, and v, which was 1. Okay, so you can find your inverse that way. but it's kind of a lot of work, right? It involved two systems of equations, and you could possibly mess up. So there is a formula for it, which you guys have learned. So hopefully you remember. It's 1 over the determinant of A, and then you switch your main diagonal. So this diagonal here is called the main diagonal. So you get D and then A, and you negate the other diagonal. So basically the determinant, if you remember, is the downwards diagonal minus the upwards. So it's going to be 1 over A times D minus B times C. You switch and negate. Oops, I forgot my negative there. Too busy talking and writing. Okay. So let's try to find some inverses and then we'll use them. So number 1 says use the inverse matrix to solve. So this is a typical question that I could ask on like a non-calculator test, right? So I want to first find A, X, and B. So A is the matrix 1, negative 1, 2, and 3. It's the coefficients. X is the matrix that just has the variables X and Y. And B is the matrix that just has the constants 1 and 7. So I need to find A inverse. So I do that by doing 1 over the determinant. So the determinant is 1 times 3, which is 3, minus 2 times negative 1, which is negative 2. I switch and negate. So I get 1 over 5, and then I have 3, 1, negative 2, and 1. And you can choose to multiply the 1/5 in, or you can leave it out front and just deal with it at the very end of the problem. It's up to you. It's really not bad when you multiply it in. All right, so that's our A inverse. So if I want to solve for X, what I do is find A inverse times B. So I have A inverse as 3/5, 1/5, negative 2/5, 1/5. And I'm going to multiply by B, which is 1/7. Okay, so when I do this, I get, let's see, 3/5 plus 7/5, and I have negative 2/5 plus 7/5. So I get 10 over 5, which is 2, and 5 over 5, which is 1. So since that's my matrix X, this is X and this is Y, right? X was X and Y. So I get X equals 2. Oops, I lost part of it. So X equals 2 and Y equals 1. And you can always check in the original and plug them in, and you should get that. It's correct. All right, now this one, we haven't talked about how to find the inverse by hand yet. We're going to do that in the next section. So I will let you just use your graphing calculator. So you guys can solve this by doing AX equals B, plugging in to find A inverse and so on. I don't think I actually did the problem, but I'll go ahead and I'll do this problem in the next section since we haven't talked about how to find the inverse of a 3×3 yet by hand. That actually involves something we learned in section 31 called Gaussian Elimination. So hopefully section 30 was super simple. It has been a little while since you guys have done this, so I wanted to make sure that you guys did know how to do it, but the homework should be super simple. All right, thanks.